Hi guys, welcome to my YouTube channel. In this video we're going to discuss about chemical bonding and types of chemical bonding. Please like, subscribe and share. Chemical bonding. So elements gain or lose electrons in order to become stable or to gain stable electron configuration. There are different types of chemical bonding present. One being ionic bonding, which involves electrostatic attraction between cations and anions, and covalent bonding, which are formed when outer shell electrons are shared by two atoms forming the bond, and then the metallic bonding, which involves bonding in metals. Ionic bonding. So cations, they are positively charged ions, and they are formed when atoms lose one or more electrons, and it is mostly found in metals. So metals have tendency of losing electrons in the outermost energy level to form ions, positively charged ions. Negative ions or anions, they are formed when atoms gain one or more electrons, and they are mostly present in nonmetals. When nonmetals gain electrons in order to become stable, they may gain one or more electrons to become stable. So when metals combine with nonmetal, the outer shell electrons are transferred to the nonmetal completely. So that is what forms ionic bonding. In short, ionic bonding is therefore a type of bonding that is formed when electrons in the outermost energy level of the metals are completely transferred to the nonmetal, therefore forming ions with opposite charges. This is the first example, sodium with chlorine. Sodium is a metal with one electron in its outermost energy level, while chlorine is a nonmetal with 7 electrons in its outermost energy level. So when this type of ionic bonding is being formed, the electron in the outermost energy level of sodium is completely transferred into the outermost energy level of chlorine, therefore forming sodium chloride. And you can see that sodium has lost entire energy level because it has lost the electron that was there. For chlorine, it has gained an X from sodium. That means that the X or the electron has completely been transferred from the metal to the non-metal. So when you look at the electron configuration of sodium, now it is 2.8. It has already lost one electron. For chlorine, it's 2.8.8 negative, meaning that it has gained one electron. And that's how sodium chloride is formed. Another one is magnesium chloride. So for magnesium chloride to be formed, we need one magnesium and two chlorine atoms. So the two electrons in the outermost energy level of magnesium are completely transferred into the chlorine. So one electron in each chlorine. So this one has been transferred to the first chlorine, and the second one has been transferred to the second chlorine. And therefore you form magnesium ion with less one energy level because it has already lost the two electrons, and two chloride ions that have each gained an electron. So in this, you see that there is complete transfer of electrons from the metal to the non-metal. Potassium fluoride is another example. Now this is an ionic bonding formed between potassium, which is a metal, and fluorine, which is a non-metal. Potassium has an electron configuration of 2, 8, 8, and 1. So that one electron in the outermost energy level of potassium is completely transferred into fluorine, forming potassium ion with one less energy level and fluoride ion, which is negatively charged ion. Dot and close diagrams. So when drawing the dot and close diagrams, it is allowed to draw the outer shell electrons of the metal without any electrons. That is if it has already lost the electrons. and the non-metal, of course, it will have gained 1 electron. So only outer shell electrons are drawn, and the charge of the ion is evenly spread. That is, you use box bracket to show the two oppositely charged ions that are produced. So this is an example of sodium chloride, drawing only the outer shell of sodium and the outer shell of chlorine. The outer shell of sodium is empty because it has already lost 1 electron, and the one for chlorine has 1 extra electron. So there are examples of dot and close diagram. For example, in formation of magnesium oxide. So magnesium is a metal, oxygen is a non-metal. So you only concentrate on drawing the outer shell electron, where magnesium with the two electrons in its outermost energy level now gives away 2 electrons to oxygen in its outermost energy level, forming magnesium oxide. Potassium chloride. You have potassium, you only concentrate on 1 electron in its outermost energy level, and chlorine, therefore forming potassium chloride. Sodium oxide, you have sodium and then you have oxygen. Now you need 2 sodiums and 1 oxygen so that each electron is transferred from a sodium to an oxygen, making it stable.